So how many people here have used Docker before at all? Just about everyone. So we've got some hope there. This actually doesn't have much Perl in it. Most of this talk is about using shell to build a working smoke environment for smoking Cpan inside of Docker. So the first thing is, what is smoking? The basic thing you get into with a smoke test is, does it catch fire? So you've got, this came from old tube systems where you were making sure the tubes worked by just plugging it in. If you had a shower of sparks, something's wrong. Smoke testing in the code is, does it build? We're not doing white box testing, we're not doing black box testing, we're not doing regression testing. Simple question, does it build? For Perl, using Cpan, that means we can grab the makefile.pl, the build.pl, we can run it, the thing survives. Now, Cpan, which is interesting, Perl is unusual among languages you find today because we actually run the tests as part of the install for everybody everywhere. So when you go into Cpan or run a build.pl and you do an install, the test is part of it. Sipan Reporter, how many people here use Sipan Reporter? Actually report the results of their tests. Sipan Reporter, what it does is it's an addition to the standard test cycle. If you install it, and I'd recommend everyone does it because it just gives us all better feedback on what's going on in the world. It sends out an email with the results of the test. So for example, every morning I wake up and I click on the little Cpan mailing and I can see places that my modules were tested on platforms I don't even own. BSD, Windows. I think the last VMS server finally died a few years ago, but I found out that Find Bin Libs actually works on VMS on a weekly basis back then, which is great as a module author, because I don't have to have a copy of BSD, I don't have to have a copy of Windows, I don't have to have 18 Linux distros, I don't have to have copies of Perl going out to 5.8 to know whether or not my code works on them. It's also great for bleeding edge, because I can find things out early before something's released, I can fix things. So Sipan Reporter Smoker, all it does is grab the recents file off of Cpan, find the new modules, and then try and build everything. There are a certain number of things that won't work with very well. Mod Perl, Bio Perl, they're just things that are too big, that have too many dependencies, that are too involved to install. But it'll take most of the things that most of us upload, and it just says, hi, do a build. If the build succeeds, that gets plastered. If the build fails, the author gets an email that says this is where it blew up and a log of it. So you need machines to run this, and where it gets is, why we smoke test. Because you think about it, regression testing, you've got an obvious reason. You want to see if something works. Black box, white. Smoke testing, there are a couple of different reasons people do it. There are different blocks of code people test. One of them is you want to verify your personal modules. So you've got a Sandbox directory, you want to go into each one and say, does whatever I have, does it work? Can I at least install it myself? You might also have something where you've got a large project. Your company's got something and you do not necessarily a weekly integration build, but one of the things you might want to do, again, for example, if you do a Cpan upgrade, does the stuff I have work well with my current upgraded version of everything? And it's easy enough to do. You go through, you make all of them. If something blows up because a module you depend on is broken or changed, you'll at least know about it. And then the real hardcore addicts are the ones who test Cpan. And that means going into Cpan, grab the recents file, or just randomly pull modules out of Cpan and just keep building them, testing them, building them, testing them. So when you go through that, then the question is, what are you going to smoke? If it's your personal space, it's going to be whatever's in your sandbox. If it's a company, that might be a number of repositories. It might be one repository and a large number of directories. But you're going to be smoke testing a bit more code, and it might get a bit more involved. If you're testing all of Cpan, does people here, you've seen the recents file on Cpan? People know what that does? Okay. It lists the recent files, literally. It just, every time somebody does a commit to Cpan, it gets tacked onto the recents file, which is neat because then if we want to smoke test it, we can smoke test everything that's new. So the standard procedure then is you take whatever is new, test it, and then just keep randomly checking things and look for changes to the recents file. But again, the unit of how much you smoke is going to affect how you go about doing some of this stuff. Now, if you're smoking your personal stuff, you can just do a make -C in all your Sandbox directories, and you smoke checked it. You're done. If it's a larger project, you might have to go to GitHub, you might have to go to someplace else, do updates, you might have to pull things in from external vendor files. But whatever you're doing, it's going to be a fairly closed environment. That's what's important about these two. If you're checking Cpan, you're going to be slurping whatever there is on Cpan, however it works. And that's where the risks come in. Smoking is not safe. We've all seen a little warning on the boxes. Now, I'm going to be, let's say I'm smoke testing my own stuff. I still have a risk because I may have a dependency on a module that gets pulled in, and I may install some bogus code because I pulled in a module that's broken. A little bit less likely, but it can happen. I might have made a mistake and fried my system. There was one great module guy, I forgot which one it was, but if you're running Cpan as super user, the guy would turn off all signals, just trap every signal with ignore, and then do a file find on slash. And then on the screen put rm-rf slash ... You know, this would go on for about 10 seconds, then a message would pop up. Why would you ever run something as root if you didn't know what it was doing? The guy got in trouble after enough people had heart attacks. But you see the point. Somebody might not have, you know, /something is easy enough to put in. And you can have stupid things, you can have malicious code on Cpan really isn't the biggest problem, but just stupidity is, you know, one space is all it takes to toast you, especially if you're testing the stuff as super user. So the risks are there even when you're testing your own stuff because you might pull in arbitrary things. If you're testing your company's code, you might be pulling in external vendor code. They might make mistakes. If you're testing Cpan, you got no idea what you might be running. There's also secondhand. There's the possibility somebody ran something that reconfigured a network interface that leaves cruft files in vartemp or in one of your varlive directories. There are leftover test files that have to be swept out. You end up wasting disk space, you can end up wasting bandwidth. If you're in a bandwidth constrained environment, you might not be wanting to run, you know, huge things. The point is that there can be side effects from testing that aren't obvious when you run the tests, and you've got to control for those. So you need to protect yourself. You want a sandbox for running these smoke tests. It should be a disposable environment. You want to be able to say, you know what, this thing is so polluted with leftover cruft from failed tests that I don't want it anymore, and start over. Virtual machines are what people generally have used for this. Problem with virtual machines is they're expensive. I mean, they cost money, but they're also a lot of work to set up. You got to have Chef, you got to have Puppet, you got to learn yet one more language for configuring an entire operating system. You got to configure the logger, you got to configure cron, you got to configure. I mean, you're running an entire operating system for the sole purpose of wanting to throw it out. Not a very effective use. For a long time, people would use cheroots for these things, but cheroot doesn't help you because it still allows somebody to mess around with network interfaces, memory, whatever. It's not really a container. It can save you from file system problems, but nothing more than that. What you really want is a way to isolate processes. And I want something lighter weight than a virtual machine, but heavier weight than cheroot. BSD jails came close, but didn't quite get there. And yeah, I'm skipping some of the stuff in here because I'm trying to cut half the talk out. LXC, has anyone here used LXC? I mean, actually LXC at the command line? It has 200 switches. Because you can control anything you want to. You can control memory, network, semaphores, resources, file systems, and you have to be able to specify all that stuff. So LXC, which is funny because it really, if you're running LXC, you are running an LPAR. Anyone else remember LPARs? How many people here remember cards? I'm just okay, so there are at least a few of us. The point is, it's a great tool, but it was so frickin' complicated, nobody used it. So Docker came along and said, we're going to give you the 80-20 solution. You can't control everything. It won't do a lot of what you want it to, but it'll do enough of what everyone wants it to that you can manage it without going nuts. And so it's got that middle road. What's important about it, do people here understand AOFS? I can save people from hearing something they already know. Not too many hands. Okay. The core of Docker is an image, is a stacked file system. I'll show you how those work in a minute. But it gives you the ability to have a copy of your operating system that is read-only, so your smoke tests can't modify the OS. And that's where it's important. So the AOFS, if you look at this thing, all that greenish stuff, I can have what are layers in my file system. The idea is I can grab an operating system, I can layer over it just a few little files for my personal configuration, and I can put that over in a corner and say, anytime I want to use it, stack these layers up like tracing paper. And the collection of all of it is what I see. At the top here, you'll notice where it says container layer. Because I need to update things as I'm running, let's say I'm running an operating system, I'm going to want to write to a log file. I may have something that updates a file in Etsy, whatever. Those changes get put on this top layer where my session is visible, but it's discarded on the way out. And that is really important for why the approach I've got here came about. So what happens is I can't make permanent updates to an image. I can update it while it's running, but the minute I shut the image down, I've restarted. Now that sounds great for smoke testing, because I can have something that splatters garbage all over the file system, and I just restart it and bang, I'm back to square one. The problem there, the minimal, I've got a layer on top that absorbs all my changes, but I can't maintain the smoke testing environment without rebuilding it from scratch. And you're going to want to take Cpan Reporter and HTTP date and the signature module. You're going to need to upgrade those periodically to keep them current. So the downside to trying to use an image by itself for smoke testing in your environment is that you can't maintain the smoke tester. So what I came up with is a hybrid approach. Docker has a thing they've introduced recently called volumes. And they allow you, they're basically mount points. They allow you to do the moral equivalent of a mount minus bind. You can store whatever you like. And I can have something that I attach to the image, I mount, but it's read-writable. I can mount it read-only if I want to. And that gives me the ability to push external file systems into the container, or mount it read-write, maintain what I'm doing, and then reuse it read-only to run the actual smoke tests. Excellent as far as I know. I've had no trouble. I've got a copy of this. If I can get through this fast enough and people will stay through lunch, I've got a copy of this running on a machine I have at home. So I can show you. The OS images, because what I'm putting on that is Perl, and I'm mapping through varlivesiphan, it goes pretty quickly. It's going to be about as fast as the native access. So what I have here, I'm going to have the operating system in an image because I can snag that quickly and easily off of Docker's hub. I then use a volume for Perl and a volume for varlivesiphan. that introduces a few kind of off-ball things, because one of the things I don't update is home. So part of this whole setup is finding ways to shoehorn all my configuration into either varlivesiphan or my Perl area. So one way to create the Perl volume, it sounds tempting, is to use something like Perl Brew and try and mount a home directory coming out. The problem with that is Perl Brew's approach of using your home directory is hard to share across users. So if I'm trying to do smoke testing on a machine, Docker, because of the way it functions, you enter as root, the Perl Brew approach gets kind of messy. It just, you get that, and then if you're trying to use this for something inside a company, some guy leaves, and now that person's home directory, all the Perl Brew stuff for it, doesn't exist anymore. So again, what I'm going to do here is I'm going to create a volume for Perl that is just mounted in opt Perl and leave it at that. So if the Perl Testers wiki, if you want to read that sometime, they've got a lot of, Dave Golden wrote a lot of good stuff on there. One thing he did is write explicit step-by-step instructions for installing Cpan Reporter Smoker, which is what I followed here. All I really did to make this work is I shell scripted his instructions and then shoved them into something I could run inside of Docker. Now, Cpan minus has its own reporting and smoking that actually work better, but they're not as well documented. So this one uses Sipan Reporter. So the first thing you have to start with is a distro. Now, if anyone was here for my talk last year about Docker and Perl, I was arguing then that what you really want is just the shared libraries. That doesn't work for smoke testing because you've got a bloody idea what libraries people would use. They might want ncurses. Who knows? You're pulling in random stuff and compiling it on the local system. So this is one of those cases where starting with an operating system makes sense because you need the libraries. One thing to make sure of is you want the version of libc in your image to be consistent with the version of libc that the kernel you're running on has. If libc is out of sync between the running kernel and what you're trying to build everything on, you can get all sorts of weird errors. They won't show up often, but you will tear your hair out finally figuring out, I should, So we're going to need GCC because some Perl modules require a compiler. We're going to need make. At that point, a lot of the really stripped down Linux distros don't work as well because you have to install 45 things after you get the distro. Arch, the default Debian doesn't come with a lot of these things. So I'm using Gen2. It uses a system called Portage that's based on BSD ports where everything's compiled locally anyway. So the baseline Gen2 distro will include GCC, make, the standard library management, all that's there in one place. So to get this, all I do is I grab a stage 3 tarball, cram it in. You can take into Docker, you can take a tarball and import it directly into an image. It becomes one of those file system layers. The thing is, you're going to want your own editor setups. You're going to want your own bash profile. Everyone's got their own tweaks to the system. So what I do is I then have just a subdirectory that's got the few little things for the root directory, maybe my etc hosts file, a couple of odds and ends. I layer that on top of the standard distro. And again, without going in too much, I don't have time to go too much about the way Docker works. I have a local repository. I put one of them in, I put the tarball as one layer into the repository as an image. I put the collection of private files on top of it as one more image. And then that secondary image that's got the personalized is what I use for running all the smoke tests. So I'm going to want to have a volume for opt, which will have opt Perl in it. Again, this is Linux. I'm using a System 5 file system. It's not user local. I'm going to want to put var temp. I'm going to want that to be a temp FS just for speed, and for the fact that I'm going to discard it every time when I'm done anyway. The other thing I need is going to be standardizing the paths. Because I've got a Perl tarball, I don't want to have to push into my script inside of Docker what version number of Perl I'm running. I want to be able to just have generics. So one of the things we'll do with the volumes here is standardize a lot of these paths. So instead of Perl dash something, it'll just be perl.tar.gz. And I can show you how to do that. It's the equivalent of a mount bind to isolate the file names. At that point, I do a Docker run. I'll take this image, mount the volumes on it, and build all of Perl. Now, Docker has a -tempfs option that says, give me a temporary file system. The downside to that is when you mount things in Linux, one of the options you have is to mount it no exec. You don't want code executing out of that space, which is Docker does to us, which makes it absolutely useless for trying to run anything that we use with our tests. So the approach I've got here, you'll see that there's a --tempfs, but it doesn't quite work for what we're doing here. So what I want to have is a temporary file system, but I might be running 8 of these things at once. How do I create something private? I'm going to create a volume that depends on the process ID that I'm using to run this. The trick is I'll have to remember to tear it down when I leave. So if I have, this is shellcode, if I have a var temp bash pid, I can then go down here, create a volume, and run it, putting this temporary volume into var temp. And I've got 10 minutes. I apologize how fast I'm going, folks. So now what I've got is a whole bunch of these volumes, and I'll go through these quickly now. I've var temp, I've got a tarball that I'm using to install Perl with, and then I've got a build script that actually runs the installation of Perl, updates the modules, does all the rest of it. I'm going to have the volume into which I'm installing Perl, which is, again, the copy of Perl that will be used to run the smoke tests. And I'm using mini Cpan to cache all this stuff so I don't waste bandwidth reloading all the same files. I'm going to put that in varlivesiphan. Also, I'm going to put the Cpan testers, anything that's permanent part of the configuration, because that stuff's completely reusable. The version of Perl doesn't matter. Now, one thing you'll notice here, there's a bunch of these things that are version specific. They have to be if I want to test multiple versions of Perl. They are all mapped onto standard locations in the file system so that I can hardwire them into my shell scripts. That's one of the advantages to using the volumes for this. The other thing is you'll notice I'm mounting varlivesiphan. So I'm using one varlivesiphan from the OS, just doing a mount of it inside of the container. There's a good and bad thing there. It makes it really easy to use mini Cpan. It's like, what, 4 to 8 gigabytes to cache all this of the current version of everything. It works just fine. The downside to that is you can't run 2 of these tests at once because the lock files will compete with one another, because I'm actually mounting the OS directly in. The quick fix, I know I dropped a slide, but the quick fix there is I could make varlivesiphan a volume the same way opt_perl is, and at that point it would be, I could have 10 of these, and for the amount of disk space it takes, and in today's environment, having 8 copies of Cpan locally, 80 gig, my notebook has enough to store that. But again, the way I'm showing it here, there's just 1 copy. So what happens is, to run this, and again, this is shellcode, I'm going to create a volume for the tempfs. I'm going to create another volume for my local that's got the opt_perl. I'm then going to run, now the -rm, good and bad to this thing, but the -rm with Docker says, when I'm done, remove the image. That avoids having problems where a crashed image competes with the name of something. But it also makes it hard to come back later and fix what was going on. One of the things I want to get through, if people are willing to stay a few minutes in lunch, is you can go through and fix the running build. So if one of the steps fails, I'll show you how to get into the container and actually finish installing all of this stuff without having to start over. T is important. That what that does is creates a terminal. It allocates a PTY for the container. That's important because there are Perl modules that will depend on getting the screen size, and if they do not have a terminal, they will puke. The name is build Perl. Names are unique. So if I have build Perl 5.24.1, there can only be one image named that running at one time. That's a good thing because I don't want two of these things hacking the same set of volumes at once. The -A's take the output from the container and give you, it basically channels those into sockets in the local file system so that I can grab the output of it and store it. By the way, this, if anyone doesn't have time to stay, I'm going to stick this on SlideShare. If you look up SlideShare Lembark, it'll be there today. There's also at the end of this, I've got all the code on this is in GitHub. It's an absolute mess of quick hacks, but if anyone wants to play with it, it's there. Lembark, L-E-M-B-A-R-K. It's just the same thing as on the. So there's the build Perl script, which again is mounted as a volume. And it's just mostly here scripts. It looks like this. Notice, I've got this subprocess. All it does, that code there inside the parentheses, will build a running copy of Perl for you. It snags the tarball, does a make test install. Important thing here, notice that I set my home to varlivesiphan because that's the permanent place. If I used /home for anything, it's on the image. When I'm done with the install, it's all going to be gone. And that's part of the weirdness of doing this is you've got to redirect a lot of things to where you wouldn't normally. One other thing to notice here, notice how long it took me to run all of the Perl tests. People say, oh my God, you're building Perl from scratch. It takes 3 minutes. This script to build all of Perl and install it takes like less than 10 minutes. So building these things overnight actually is pretty easy. Now, if you wanted to test building Perl, let's say you're doing bleeding edge testing of Perl, instead of using the volume where it's just local, use a tempfs for the opt Perl. Run this script. When you're done with it, discard it. You've just tested, you've smoke tested building Perl. So if you have opt on a tempfs, it is very, very fast and very easy. You do it, you run it, you discard it, you're done. So to test the bleeding edge using the same technique, what I would do is go to a Git repository, I'd do a git pull, and I would mount the volume the same way I did varlivesiphan. And I would just have, I'd mount my Sandbox, Perl, whatever, in opt Perl. And I can now test all of this stuff using today's bleeding edge. So that the same technique with the volumes works both for testing the bleeding edge, it works for testing whether or not Perl itself builds, and you can use it for testing all of the modules. Let's say you're asking the question, let's say your company likes to keep up to date on Perl. Hopefully. You can do a very simple smoke test of all of your in-house modules and all the modules all your code depends on every day by just doing a git pull and running the same procedure. Now, there are a couple of minor setups we've got to do. Again, once I've installed Perl, I want to hack the path because I want to be using my copy of Perl. The other thing is H2PH. This is a good check to make sure that Perl installed. If the install blows up here, you know something went wrong. There are a few things here, varlivesiphan, the remote, pick your own remote if you grab this thing. One of the things in the code, in the stuff on GitHub, are some variables like my name and my pass. Kindly do me the favor of changing those, especially the email address. So this is what it takes to configure a working copy of Cpan so that it stores everything in varlivesiphan instead of home. Again, if I put things in home, I'm fried because as soon as I exit the container, all my changes are lost. So what this will do is put everything in varlivesiphan sources, whatever it uses var temp cpan, the temp FS, for all of its builds. Now, one of the things I probably want to check to see if smoke testing is going to work, let's try installing Cpan. if that doesn't work, I'm going to have worse problems. Term reline Perl is cute. Everyone here remember installing that? It goes halfway through and has a little prompt where it wants you to type something, hit return for exit. If anyone can figure out how to bypass hitting the bloody return key, because I think it actually reads from the frickin' terminal. I've piped yes into it. I've done all kinds of weird-ass things. But this is one of these two modules here. Don't just take yes for their responses to install. So I had to do these with here scripts. This collection of crap is the stuff. Huh? Yeah, I tried setting that one, and if it doesn't, anyway, if anyone finds a good way to deal with that, feel free to put it in. These are the modules that I install as part of the smoke testing environment. I'm not smoke testing these modules. I'm saying these are things that we're going to want to have. Sipan Reporter, HTTP date, signature, module version. All of this stuff is pretty much needs to be there in order to run smoke tests. So again, the Cpan testers directory that's got my the authentication information can't be in home because it's going to get lost. You're laughing. Oh, okay. So yes, password/secret. It is not the most descriptive password, but this is enough to create a working authentication. Cpan Reporter, when you configure it, this is a working configuration for Cpan Reporter. And the fun part starts now. You're running all of this, and you want to see what's going on. You can fix the build with Docker exec. A lot of people will show you examples of doing a Docker, like doing an SSH into a container to see what's going on in it. That's a waste of time because you don't want to sit here and configure all of SSH to go in and watch this build. The Docker exec command will go into a container and run a statement for you. It just gives you another process inside of the container. Did that make sense to people? So if I want to fix a build, if I want to watch it, so if I do a Docker exec -IT, again, I want a terminal, I want standard in bound to it so I can type on it. But I can just do top. What's neat about this is all I'm going to see are the processes inside the container. The rest of the world, you run top when you're doing a large Perl build and you got 55,000 other things going on the machine. With this, you'll see only the processes that have been forked off since the container started. So we've all seen little things like this when you were trying to build something. So what do? So the question is, how do you fix something like this if it happens when you're trying to build your smoke testing environment? And the answer is you exec into the container, and you can do a bash -login. Oh, God, I forgot it. Take the quotes out of that. Actually, it has to be bash login with spaces. That's my mistake. What'll end up happening then is you're going to be in the container running a shell. You can do a Perl -m cpan install whatever. The way the current code is written, because it's one big script from top to bottom, you then have to cut and paste a few things. Eventually, I like to break this thing up into something that's in stages, and you can just rerun it, and it'll say, I've pre-run these and keep going. But this is how you fix something. You don't need to SSH into it. A lot of books, a lot of articles tell you how to set up your Docker environment so you can SSH into the containers. Complete waste of time for doing something like this, unless, of course, you're doing it on a remote machine. Another brief thing. if you do a Docker PS, containers have a name and they have an ID. So you'll see here there's a hexadecimal number, and there's build Perl 5.24.1. I can exec into either one of those. A lot of times if you're doing this from the command line, it's just easier to cut and paste the number, but you'll get the same result. You'll be inside the container. Now, have people here ever SSH'd into or exec'd into a Docker container? You've seen how it works? Not many. Okay. It's weird. This is a through the looking glass experience. Part of it is, inside the container, you're super user. You come in and you're root. But you're root inside of the container. Outside of the container, the kernel still thinks you're the process ID that ran the container. So you're super user, but you can't mount anything, you can't unmount anything. All it really does is give you complete access to the file system inside the container. Is about the only real root-ish thing that you have. It means you got to be careful when you remove things. You can't fry the entire operating system. But it's a little bit odd, especially if you've got scripts that check for whether or not you're super user for sanity checks going in. You're going to trigger those sanity checks inside of the container. Again, PS, if you do a PS minus a PS AOX, you might only see 4 processes because that's all the container has inside of it, which is great when you're running a build. You don't have to see everything everyone on the machine is doing. The other thing is that run level restrictions don't work because you're always running, you're really not booting anything, so there's no notion of run levels. You can run Perl -m Cpan, you can do make install, you can do all those kinds of things. If this script blew up or if some piece of your smoke test environment needs maintenance, you can use whatever tools you like to maintain it inside of the container. That AOFS, it takes some getting used to because you do a CD and you're in /root because root's home directory. You change something. The next time you come back, that change will be gone. If you want to modify something in Etsy, the next time you come back, that change will be gone. That's why if you look, I set home to varlivesiphan earlier in this because that varlivesiphan is where I store the common configuration information for running the smoke tests. Mini Cpan, do people know what that is? It basically slurps the most current version of everything on Cpan into your local file system. The point to that is if I'm running smoke tests, I will pretty often have modules that drag in other modules that drag in other modules. Why waste bandwidth re-downloading them a bazillion times? So, and remember, I'm not installing anything when I run these smoke tests. I'm not putting anything into my opt Perl. I'm just doing the build and test and skipping it. So if I pull 14 modules in, I'm going to have to re-download those things every time I run into anything that uses them. So running the mini Cpan can save you a lot of bandwidth when you're doing smoke testing. But again, that has to update varlivesiphan, the shared permanent space for all of this. So now the life cycle for smoke testing is you run mini Cpan, update varlivesiphan, you run the smoker inside of a container. Now that running the smoker, I'm going to have that Perl volume in opt Perl. I'm going to mount that read-only because I don't want these things modifying Perl. I want to just see if they work. If somebody wrote something in their makefile.pl that tries to modify it, it's going to puke. Now, one other thing here, the one advantage to virtual machines for this kind of testing, I can only test one version of the kernel this way because everyone's got that kernel. So if you're a company and you're looking at upgrading your corporate system to a different version of something, you might want to run Docker inside of a virtual machine with that upgraded kernel. But you're only going to get the version of the kernel that is running outside of Docker to test this with. Did that make sense to people? And that's one of the trade-offs for using Docker. Zombies. One thing you'll notice, and this is part of the through the looking glass experience, when you start up a process inside of a container, the initial command will be PID number 1 inside of the container. Outside of the container, it'll have a normal PID. Inside of the container, it's number 1. When it exits, the container shuts down. But that also means if you don't want to bring the machine to its knees with leftover procs, you have to reap them. Because there's no standard issue init inside of this container sucking up all your zombie processes. So I forgot to do this recently and couldn't get back into the machine because I'd exhausted the process table. Only super user could get into the machine. So one of the things that's in here is a wrapped version of the Cpan Reporter that forks, and then the parent just does a wait and discards processes. So the fork and reap, basically, the parent does something like this. I wait. I was past the child that I'm actually running the install with, or I'm running the smoke testing with. When that exits, I have to exit. At that point, the container shuts down. But it's sort of a fake, it's a runt version of init that will just reap the processes. And again, that's in GitHub. So in order to run the smoke tests, and we're almost done, I want to take my Perl volume, but this time I'm mounting it read-only. Then I have to mount Cpan on Cpan. I create my temp volume. And this looks a lot like what you saw before when I was running the build. It's just start up a Docker container running Cpan tester's Docker Smoker, which is the thing that does the fork and the reaping the processes. One thing I'm going to propose, I may be dumb enough to inherit the code for doing this, would be that we change the Sipan Reporter Smoker. Right now, it goes through the recents file, and then it keeps going. And I would like to have an option where it goes through the recents file and then exits. Because the sexy thing about that would be I can do a product of X number of versions of Perl and just iterate for all these versions of Perl, see what happens on the recents file. And if the thing doesn't exit, I can't do that. I've got to actually kill it in order to make it go away. So anyway, the real thing is Cpan smoking is not hard to do. It is something that we as a community can do to make Perl better than other languages. One of the things, if you want to talk to somebody about, why bother and use Perl, the level of testing and test information and metadata about tests and what fails and what doesn't, your ability to write a module and put it out there and find out where it runs is better on Perl by far than any other language. And doing this, it's easy to contribute to that. And Dockerizing this means we can have, for the Perl community, we can have bleeding edge, we can have older versions, newer versions, different versions of everything. In a corporate environment, doing this makes it really easy to say, what happens if I upgrade my Perl version? What happens if I do a Cpan upgrade and upgrade all my supporting versions to get all the, the people that are running 5.8.8 because, oh, it might break. Well, you don't have to wonder if it breaks. You can stick this smoke test into Docker, build everything. It's not hard once you've done this to do all your regression tests inside of Docker. And you can prove to yourself that the next version of Perl runs everything. And that is it. If anyone cares, it should be somewhere here. It didn't die already. Nope, it died. If anyone cares, I can open up a session on a machine that's got Docker installed on it, and you can actually see what it looks like running this. If not, are there any questions? Does anyone here have a heartbeat? Okay, we got at least a few people. I didn't kill everyone.
This is people that work on talks. There's another system here that allows you to go to the room and not have to go to security. That's its room perspective.
Yeah.
So you have a talk in other rooms, except for that is you have to go to security. Different partnerships. If you have a talk, which is just on the street, or you have a seminar,